How systems work. A system is a group of elements that use energy to work. That is a very important definition. The word system, the word elements, the word energy and work are connected. And this is an energy transfer or Sankey diagram. So we need to understand these words to understand that everything in nature is a system that uses energy to work. Now we have seen that there are 5 elements in nature, and the elements are associated with 5 systems in physics. Electric systems for ether, hydraulic systems for water, pneumatic systems for gases, mechanical systems for bodies, the earth, and thermal systems for the element fire. Now, to understand how each system works, we need to define for every system a variable. We could say that a variable is what moves in the system. We can identify it with the letter X for variable. So the symbol is X. In an electric system, like lightning or any circuit, we have to think of charges that are moving. In an hydraulic system, we think of volume of water flowing. In air, when we think about wind, we think about a mass or a volume of air. On earth, we think about masses. And when we talk about the fire element, we speak about heat. What comes from the fire, what comes from the sun is energy in the form of heat. So this is what moves in a system. Everything that moves in a system has to be pushed in order to move. So what pushes the variable is what we know as potential difference, and this is a symbol, the delta V. In electricity, it is the voltage or electromotive force what pushes the charges. In water, it is a pressure what pushes the volume of water out of the container. It is the atmospheric pressure what pushes the air in and out of our bodies, or the difference of pressure between our lungs and the atmosphere, what creates the flow of motion of air. There is gravitational potential, what pushes the masses, what pushes the apple to fall down the tree, we call it gravitational potential. And what pushes the heat is called temperature. So temperature is not the same as heat. Temperature is potential difference. So we identify this, the potential difference, with the letter delta. And it's also defined. We have to accept this if we want to learn science, if we want to learn physics. We have to accept these words like principles. Now energy. Energy is what the system uses to work. If you have voltage and you have charges in a circuit, then you have electric energy. So the electric energy is the product of the voltage multiplied by the charges. This is known as Joule's law in a circuit. There is hydraulic energy, for example, in a Pascal press, when there is a difference of a pressure and a volume that is being pushed by that pressure. Hydraulic energy. Boyle's law for air, pressure times volume. Pressure times volume is the energy of a gas inside a gas. You can increase the pressure and decrease the volume, or vice versa. In mechanics, when you have a potential gravitational and a mass in that potential gravitational field, then you have mechanical energy or gravitational energy. And the solar energy, since the sun is the first source of energy, we could say that energy is what comes from the sun, and the source of energy in the sun is the fusion of hydrogen atoms. So the sun is transforming fusion into heat. light, and all the other forms of electromagnetic energy. Basically, in order to have energy, we need to have these two lines, something moving and something pushing. So that is a law for energy. And the two laws in thermodynamics, the first law is the conservation of energy, and the second law is that no system is 100% efficient. There is always energy being lost to the surroundings. The idea of flow, motion of the variable in time. So when the charge is moving in time, we have current. The volume moving in time, we have the flow of water. A volume of air moving in time, we have the flow of the wind. A body falling in time, it's just falling bodies. And energy from the sun moving in time is solar power. Flow. Resistance. What allows and opposes to the flow. If we are talking about electricity, we can identify a resistor, Ohm's law, as what allows and opposes to the flow of charge. If we talk about the blood in our system, the veins, the arteries are the resistance. Or we could think of a tab as a variable resistor. Water is allowed to go through, or blood is allowed to go through these pipes. Those are the resistance. For the element air, the nostrils, the resistance to the flow of air. In friction, bodies moving like a ball moving, the resistance to the motion of bodies is known as friction. And in fire, the electromagnetic radiation that comes from the sun either goes through space, that means radiation, or is transferred by fluids, that is convection, or is transferred by solid matter from vibration of molecule to molecule, and that is conduction. So basically these are the ways in which energy flows through resistances. Capacitance, ability to store and release energy. In electricity we know these as capacitors. On Faraday is the charge per unit voltage that can be stored in a capacitor. The liquids are not very good for absorbing, retaining and releasing energy, so they're very good for transporting this energy. Heart is a good example of a capacitor. It does not absorb and retain for a long time, it just pushes the energy. Lungs are air capacitors in our body. They store and release volumes of air, increasing and decreasing the pressure in the lungs. A spring is a capacitor, or anything that is elastic is a mechanical capacitor. Hooke's law. And the concept of capacitance applied to the element fire is the definition of heat capacity, the ability to store energy and increase the temperature. So the formula for capacitance is variable over potential difference. And the last concept that we need to understand is the concept of power, meaning rate of work. Energy divided by time. If we talk about electricity, we're talking about transformers. They transform voltage. They could step up or step down the voltage. If we talk about hydraulic, we talk about hydraulic power, the transformation of pressure and flow into electricity. If we talk of wind power, we can see how the plane flies, how the pressure and the flow play on either side of the wing to decrease or increase the pressure and keep the upthrust of the plane. In mechanics, it is force and it is velocity. The gear systems, they either increase the force and sacrifice velocity or vice versa. And in fire, solar panels are transformers of solar energy into electric energy. Basically, the idea of power is that of transforming energies from one forming to another. And the formula is energy divided by time, or we could say potential difference multiplied by flow would give us also a formula for power. So this is the web of concepts, the second matrix that we must learn. If we start erasing the words, the drawings from these concepts, from these web, we'll end up having just the definitions and the laws. If we take away the definitions, we'll just have the laws that we need to know for all the elements of nature. We take away the laws and we only have these words that we need to understand what they mean. We take away the words and all we have is empty space. And from there we start to meditate on physics.